Alright, I said we were going to look at slant asymptotes next. We're actually going to save that probably one more video before we do that. I want to do I actually want to go through graphing one of the rational functions that we have so far without actually doing one of the slants, and then we'll come back to a slant asymptote and what that is. So let's kind of go through all the different things that we need to do in order to graph one of these. So let's start off with f of x is 2x minus 1 over x minus 1. Alright, so we need to look for all the different things that we've talked about. The very first thing we should probably look at is the domain. So let's go ahead and define our domain. So we're going to define the domain by looking at the denominator. What things from the denominator would make the denominator 0 so that it's going to cause a problem? Well, the only one that would make only value that would make the denominator 0 is x equals 1. So we would have to say that the domain cannot include 1. So when we write our domain, it's going to be from negative infinity up to 1, and then in union with 1 to infinity. There's our domain. And the good thing is, once we've found that, we're going to actually have our vertical asymptote, because remember that whatever makes the denominator 0, as long as it doesn't also make the numerator 0, in other words, as long as there's not a way to have the same factor on the top and the bottom, that's going to be your vertical asymptote. So we actually have our vertical asymptote as well. Our vertical asymptote is the same location that we can't have in the domain, so it's going to be x equals 1. That's going to be our vertical asymptote. Okay, the other thing that we have to look at is our horizontal asymptote. And remember that the horizontal asymptote, what you do is you compare the degree of the numerator and the degree of the denominator. If the degree of the numerator is bigger, then there's not going to be a horizontal asymptote. If the degree of the denominator is bigger, there's going to be a horizontal asymptote at y equals 0. And if they're the same, which is the case here, because the degree of the top is 1, the degree of the bottom is also 1, because that's the highest power of the exponents, then you divide the leading coefficients. So my leading coefficients here are 2, and since there's nothing written out here in front, it's 1. So it's really y equals 2 over 1, or y equals just 2. 2 over 1 is 2. So there's my horizontal asymptote. Okay, the other things that we need to talk about, and we've talked about this in prior sections, is we should probably try and figure out what the x and y intercepts are. So the x-intercepts are going to be whatever makes the numerator 0. Again, it cannot be a common factor with the denominator, but it's going to be whatever makes the numerator 0. So to find the x-intercepts, you're going to take the numerator and set it equal to 0, and then we're going to solve that. So if we add 1 to both sides, and then we divide by 2, we have an x-intercept at 1/2. Now remember, an x-intercept is a point. It's an actual point on the graph. It's a point where the graph crosses the x-axis. So we're going to write it as the point 1/2, 0, because the x value is 1/2, and since it's the x-intercept, the y value is 0. And the other thing that we're going to talk about is the y-intercept. And this is probably the easier one to do. The y-intercept is what you get when you plug 0 in to all of the x's. So that would give me 2 times 0 minus 1 over 0 minus 1. On top, 2 times 0 is 0, minus 1 is minus 1. On the bottom, 0 minus 1 is minus 1. Simplifying, negative 1 divided by negative 1 is positive 1. So my y-intercept, also a point on the graph, is the point 0, 1. Alright, so that is pretty much everything that we're going to need in order to sketch this graph. And that's what this will be. It will be a sketch. It'll be a loose sketch of the graph. There are many, many other things that we can do in the future math courses to make this graph much, much more accurate. But for now, this will be fine. So let's go ahead and 1, 2, 3, 4, 5, 6. We'll go out 6 in each direction. I think that should be plenty good enough to sketch our graph. Okay, let's start with graphing the asymptotes. I think those are probably the easier things to graph. So let's graph x equals 1. Well, x equals 1 is right here. It's a vertical asymptote, so the line will go vertically. And when we sketch an asymptote, we sketch it just like we did the axis of symmetry. We sketch it as a dotted line because it's not really part of the graph, but it's a good way for us to represent where this place is without actually including it as part of the graph. So there's our vertical asymptote, x equals 1. We have a horizontal asymptote, y equals 2. Well, here's the y value of 2. Once again, this is not actually part of the graph, so we'll sketch it as a dotted line. And there is our horizontal asymptote. We have a couple of points. Let's go ahead and plot those points. We're going to plot the points. Let's see. The x-intercept is when x is 1/2. So it looks like it's right there. And the y-intercept is when y equals 1, which looks like it's right about there. Okay, so now when we take a look at this, the general idea is pick a couple of points that are going to help you to define the shape of the graph. Well, remember, as a function approaches a vertical asymptote, it cannot touch the vertical asymptote, it cannot cross through it. So as the function starts to approach the vertical asymptote, we want to figure out, is the function going to go up or is it going to go down? Hopefully you can see by the two dots that I've already plotted, as the function approaches the x value of 1 from the left-hand side, these two things are already going in this direction. It's just going to continue to go down. Okay, it's not actually going to curve back up. I'll try and explain to you why that is in a little bit. As the graph goes towards the left, well, it's got to approach its horizontal asymptote y equals 2, so it's going to look something like this. Okay, and in general, this is the way most of our graphs are going to tend to be. We're not going to deal with the really complicated ones, at least not in the beginning here. However, we know that the only value that we had to eliminate from our domain was x equals 1, which is where our vertical asymptote is, which means that as x goes to the right, x equals 2, 3, 4, 5, all those values are going to have values on the graph, so we have to kind of figure out what they are. So let's go ahead and take a value to the right of x equals 1. Let's make it an easy one. We'll start with 2. So if x equals 2, let's go ahead and write this down here. If x equals 2, let's plug 2, so we'll do f of 2, into our function. That would be 2 times 2 minus 1 over 2 minus 1. Simplifying that, the top is going to give us 4 minus 1, which is 3. The bottom is going to give us 1. So we get out 3. So when x equals 2, y equals 3. Let's go ahead and plot that. When x equals 2, y equals 3. So that's going to be right 2, up 1, 2, 3. There's a point right here. Okay? As x equals, well, let's just do one more so we can get a good trend here. If we do f of 3, let's see what that gives us. If we plug 3 in, we get 2 times 3 minus 1 over 3 minus 1. 2 times 3 is 6, minus 1 is 5, and then 3 minus 1 on the bottom is 2, which is 5 halves, that's 2.5. So when x is 3, it's right 3, 1, 2, 3, up 2.5, 1, 2 and a half. Should be right about there. So you should be able to see the trend. As the values on the right side of the green line of our vertical asymptote start to approach the vertical asymptote, you should be able to see they are trending up. So that means that this is going to keep going up. It's going to ride the vertical asymptote, but it won't actually touch it. And then as it goes to the right, it's got to approach your horizontal asymptote, which is like this, and it won't actually touch it. And that's what that graph is going to look like. It's, again, this is a general sketch, but those are the pieces of information that you're going to need to find. Now, what we can also have is, what you can have is a slant asymptote, which means that you're going to have, instead of a vertical or a horizontal, you're going to have something which has some kind of an angle to it, a slope to it. And that is the third type of asymptote that we have to talk about. And we'll go through that, and then we're going to go through a couple of full examples using everything and what we're looking for as far as how to graph it.